In this video, we will discuss about the electric current and voltage. Let us consider two buckets of equal capacity, and let them be interconnected somewhere in between, with the passage closed. Now, let's fill up bucket 1 with water, and open the passage. Then, the water flows from bucket 1 to bucket 2, through the passage, until the water levels become equal, in both buckets. By observing this experiment, we can say that the water was flowing because of the difference in the water levels, or the potentials of the two buckets. This rate of flow of water across the passage is called the water current across the passage. And the water level difference between the two buckets is called the potential difference. Now, in the same way, let us consider the two buckets as two terminals. And the terminal 1 is full of electrical charges, and terminal 2 has less electric charges. And let the passage be a conductor. When they are connected, due to the difference between the number of electrical charges, these charges flow from one terminal to the other terminal. In this case, the rate at which the charges flow through the conductor is called electric current. The current flow, in conductors, or metals, is due to free electrons. Whereas, the potential difference between the two terminals is called the voltage, or electromotive force. Now let us assume a battery. The battery contains a negative terminal, and a positive terminal. Due to chemical reactions inside the battery, more number of electrons are created at the negative terminal, and less number of electrons are created at the positive terminal. This difference in the number of electrons between both the terminals will create a force. This force, or the electric potential difference, is called the voltage, or electromotive force, EMF. So, the voltage across the terminals, A and B, that is VAB, is the difference between the potential at the terminal, B, VB, and the potential at the terminal, A, VA. The voltage is denoted with V, and measured in volts, V. The voltage is also defined as the amount of work done to move a unit charge from one point to another. That is, V equals W by Q volts. Here, Q equals charge. W equals work done for moving charge. When we connect the battery in a circuit, the voltage will try to push the excess electrons towards the positive terminal. But chemicals inside the battery acts as a roadblock and will not pass electrons through it. So the electrons will search for an alternate path. That is, the electrons will pass through the wire, or conductor, and finally reaches the positive terminal. The rate at which the charge carriers flow through the given surface is called the electric current. The electric current is denoted with I equals to dQ by dt. The current is measured in amperes, A. The current, I, can also be defined as the number of charge carriers, Q, that can pass through a certain point in time, t. That is, I equals to Q by T. In this video, we have discussed about the electric current and voltage.